So in today's video, we're going to be talking about related rates. So related, obviously they go together, and rates, if you remember, we used to talk about the derivative of a function as the rate of change. So obviously this tells us we're going to be dealing with derivatives today. So a typical example is we have some sort of object, so say a pool or a box or something, and we're filling it with something. So here we've got a pool and I'm filling it with a bunch of water, and I want to know how quickly I'm doing so. So say I have to know a couple of things. So say I know that I'm filling a pool at a rate, so filling at a rate of, let's say, 3 cubic feet per minute, okay? And I know that the length of my pool is equal to half my width, or I guess 2 times my width, because that would make it the other way around. Anyway, the length of my pool is 2 times the width of the pool, and I know that the width is 10 feet, and I want to say how quickly is the water level rising when the height of the water is, let's say, 2 feet. Okay, and obviously this is much deeper than 2 feet, because why would you want to go swimming in 2 feet of water? I wouldn't. And we're also going to make the assumption that it's just a flat bottom, like when a racing pool or something like that, so there's not, we don't have to worry about, deep end or any sort of slants like that. So this is all the information in the question. Normally it gives you it in a nice paragraph. I'm too lazy to write out a paragraph, so we have this nice little thing going on. So I'm going to teach you something today that my high school teacher taught me, and that I'm now teaching to you. So if you ever run into a man named Greg Gazzola, or if you're watching this, thanks so much. So I'm going to teach you GURDS. Yep, GURDS. So what this stands for is given, unknown, relation, derivative, and substitution, or I like to say solve. So with these 5 steps, we're going to be able to solve any related rates question. So luckily, G is the first thing that happened. So we know that we're filling at a rate of this. So this is going to be, if we're filling it, that means we're changing the volume. So this is going to be, because it's a rate, dV by dt. So the volume is changing over time. We know that it's volume over time because we can examine this. Feet cubed, that obviously has to be volume. And minutes is obviously time. So we know that that has to be dV by dt. So we know that, and we know that's equal to 3. Okay? So here we know that the width is 10 feet. So we're going to say W is equal to 10. Notice that we're in feet, so we don't have to worry about units here. And then length is 2 times the width, so we know that length is equal to 2W is equal to 20. Okay? So what's our unknown? Well, we want to know how quickly is the water level rising? So at what rate is the height of the water increasing? So we know that this is going to be dH by dt equals question mark. Also, we want to know that the height is currently 2 feet, so we're going to go up and we're going to include that with our given, and we're going to say h is equal to 2. So we can say that there, or we can say here at h equal to 2. So we can put it in either here. So we know that h isn't always 2. We just want to, that's the point we want to solve the derivative for. So it's basically, we can find out the slope of the tangent, but we have to have a point to actually get a slope value. Otherwise, we just have a way of figuring it out. Okay? So now we move on to our R. So this stands for relation. So here, how are these things related? Well, they're related by the volume of this pool. So we have the volume is equal to length times width times height. So that's pretty simple, right? So we know that length is 20 and width is 10. So we have V is equal to 20 times 10 is 200 times H, right? So that was pretty easy. So now what we want to do is we're going to take the derivative, okay? Notice that we've got a dV here and we're looking for dH by dt, okay? So we have d, and we're just going to take the derivative. Now, we're going to take the derivative with respect to time. Notice here that we're taking the derivative with respect to time in both places. So this means, but we don't have time in this equation. So this means we must use implicit differentiation. Okay, you must do that or you're going to get totally the wrong answer. So when I take the derivative of v, I'm going to get dv by dt, okay? Then I'm going to get 200, well, it's multiplied by h, so 200 just stays around, and I multiply it by the derivative of h. Well, the derivative of h is just dh by dt, okay? So now, that was pretty easy. That's it. That's all I have to do for the d step. Now, I do the s step, where I solve. So all I do is I come back here and I put all my stuff in. So I have 3, dv by dt equals 3, so 3 is equal to 200 times dh by dt, okay? Well, that's what I'm looking for, so I just do 3 divided by 200 is equal to dh by dt. And that's my final answer. And I just have to say, and notice we didn't use the at h equals 2 because this is a constant, this is going to be a constant rate. And that happens. Sometimes you have extra things that you don't end up using in your question here. So don't freak out if at some point, you know, you're like, oh, but I never used h equals 2. Well, that's fine. We didn't need it this time, and that's okay. All right, so this just kind of shows you GURDS and shows you a very simple way of using it. Let's do another example. So this time we're going to look at a cone. So cones are kind of tricky. So if we take a cone, and obviously what are we going to do? We're going to fill the cone with water, because why would we do anything other than fill something with water? It's math. We love filling things. So if we have a cone, let's say that we're filling the cone. Let's say that the height of the cone, the height of the water in the cone, so this little thing, this is changing at a rate of 2 inches per minute. Okay, 2 inches per minute. Okay, the radius of the opening is 8 inches. Okay, and the height, total height of the cone is 6 inches. Okay, so you get 8 and we have 6. Okay, so now what we want to do, and that's it. That's all the information. Or no, we have to know what we're looking for, and we're saying how quickly is the volume changing. So how quickly are we pouring water into this thing when it is filled? To 3 inches high. So when it's 3 inches, how quickly are we filling the volume? Okay. So there's a couple of things. So first we're going to write down the given. So GURDS, given. So we have dH by dt is equal to 2. So 2 from here. The radius at the opening is 8. But notice that as we go down, the radius is going to change. So we can't just say that the radius is 8 and leave it like that, and that the height is 6 and leave it at that. We can't say that. We need to find a way to relate the radius and the height, because they're both changing, right? But we can only we only know dH by dt, and we're trying to figure out how much the volume is changing. So we know that we're kind of stuck when it comes to the radius because we don't have any information about how the radius is changing. Okay, often this happens in related rates. So there's generally one or two things. Before we had the length and the width were related. Now we're gonna see how the height is related. So notice that we've got this nifty little triangle. So we know that the radius is 8. We know that the height of the cone is 6. Okay, so we're looking for when the height is filled to 3 inches high. Or we want to, actually not even, we want to know how radius are related. And we know that this is equal to r and this is equal to h. Okay, so we're going to take this angle and we're going to take tan, so opposite over adjacent. So tan theta is equal to 8 over 6. Okay? Right? But they're related triangles. So even when we're down here, like say like this, they're still going to have that same theta, right? Because we're not changing the side of the cone. So tan theta at any point in time is equal to the radius over the height. So we can say that 8 over 6 is equal to r over h all the time. Okay? So what we want to do is we want to get r in terms of h because we don't want r's kicking around. So we say r is equal to 8h over 6 is equal to 4h over 3. Okay, so that's one of the other things that we know. We also know, so now we want to say what are we looking for? So the unknown. What is it that we want to find? And we want to find how much the volume is changing, so dv by dt at height equals 3. Okay, so let's find the rate. Well, I'm sure all of you have memorized the volume of a cone, right? So I googled this. It's 1/3 h pi r squared is equal to the volume of a cone. All right, so we don't really want this, right? We have r here. We want to switch this out. We don't want to deal with r. We don't want to differentiate r because we don't really know. We have dv and we have dh, and we don't want to have this extra r thing, you know, flying around. So what we're going to do is we're going to replace r with this function of h. So we're going to have 1/3 h times pi times 4h over 3 squared. All right, so now it's going to take a little rearranging. Trust me on this. So you get 16 over 27 pi h cubed equals v. Okay? So this is our relation. So what's the next? D, derivative. So we're going to do implicit differentiation. All right, so 16 over 27 times pi, well, that's a constant. It's going to stay, and then the h, we have to do the derivative of the outside first, because when we're doing implicit differentiation, we always have to apply chain rule. So we get 16 pi over 27 times 3 h squared, because of the derivative, times the derivative of h itself, so dh by dt, and that's going to equal dv by dt. All right, so now that we have this, we can solve. So we plug in everything we know. Well, we know that h is equal to 3 because that's where we're trying to find it. We're trying to find dv by dt at h equals 3. So we go 16 pi over 27 times 3 squared dh by dt equals, and dh by dt, well, that just equals 2, sorry, so this is times 2 is equal to dv by dt, so we have dv by dt is equal to 32 pi. 3 times 3 squared is 27, so they cancel, and then 16 times 2 is 32, and the pi came. So this is our final answer. All right, so hopefully this new method of GURDS will help you find and solve all related rates problems. It's a really nice way of doing things. Good luck, and I wish you well. Take care. Bye.